So I'm gonna wait for 2 more minutes.
Okay.
2:35 we can start. So one more
Okay.
minute. 2:35 we
Okay.
can start.
Okay. So let us start. It is 2:35. Now, in the first class, we have seen the basic definition of the data structure and what are the types of data structure, primitive and non-primitive, and what are the advantages of using data structure, why do we use data structure, how an algorithm is evaluated, or how when we will say that the two algorithms among the two between the two algorithms, which one is better, and how to calculate the time complexity of an algorithm. Okay, and lastly we have seen the sparse matrix representation, and today we will move on to the linear data structure, or you can say non-primitive data structure, which is the stack. Today we will look into stack and queue, and if there is a time, then we can move on to the linked list also. So first of all, stack. Now, as you know that what is stack? Stack is actually a linear list uh, that allows the insertion and deletion of the element at only one end. Okay, this is called a stack. So there are mainly two operations which are involved. There is also a third operation, but two are the main operations, which are the insertion operation and the deletion operation. Now the insertion operation is called the push operation, and the deletion operation is called the pop operation. And the most accessible elements in the stack is known as the top. Okay, you can see the diagram. This is a stack. Just see the diagram. So A is inserted, then B is inserted. Okay, and if we try to represent it using an array, it will look like this. So insertion and deletion can only be performed at only one end, which is at the top, and the elements can only be removed in the opposite order from which they are added to the stack. That is, it is known as, or it follows a LIFO order, last in first out. So the element which is inserted at the last will be the first element that will be out of the stack. Okay, so this is called LIFO. Now there is a top pointer which keeps track of the top element. Okay, I told you insertion and deletion can only be made from one end, that is from the top. So there is a pointer which is defined, and that keeps track of the position of the stack, how many elements are there in the stack. Initially, when the stack is empty, the top has a value of 0. So when the stack is empty, top will be defined as 0. And each time a new element is inserted, the pointer will be incremented by 1. And each time when an element is deleted on the stack, the pointer will be decremented by 1. Okay. Now, what are the applications of stack? Recursion. It is used in recursion. It is used for keeping track of the function calls. It is used for the evaluation of the expressions. We will see when we will go further in the slides. The evaluation of the expressions, the infix to postfix to prefix. Okay. In the reversing characters, it is very easy for reversing characters in the stack. You put each the characters in the stack one by one, and you just print it in the reverse order, so it will reverse. For servicing the hardware interrupts for operating system, I don't know how many of you is aware of the operating system. In operating system, the hardware interrupts are done using the stacks. These interrupts are kept in stack one by one, and they are serviced based on the criteria of the stack. And for solving the combinatorial problems using the backtracking, the expression conversion I told you, infix to postfix, infix to prefix, game playing also, like chess. In Microsoft Word also, the undo and redo. For compiler, for the parsing syntax and expression. For finding the paths, optimal paths. Okay, so let us now look at the I told you there are two operations possible for the stack. One is push, and the second one is pop. Push is for insertion and pop is for deletion. So let us look at the algorithm. This push s comma top comma x. Okay, so push is a function having three parameters. What are the parameters? S, top, and x. So what is x? X will be the element which is inserted, suppose. And the stack is represented by a vector s. Suppose there is a vector s which is representing the stack, and it contains n elements. Okay. And what is top? Top is the pointer which represents the top element in the stack. Now let us look at the algorithm. First, when we are pushing into the stack, we will look for the stack overflow. We will check for the stack overflow. Okay. Suppose there is already, I told you the vector S is having n elements. So there is already n elements existing, and still you are trying to push one more element. So the stack will be overflow. Okay. So it is similar to like array. In array, if you have defined an array of 10 elements and you have entered 11 elements, so the 10 elements will be inserted, but the 11th element will not be inserted. That will the overflow. Similarly in stack also. So what will you check? If top is greater than equals to n. If it happens, then stack overflow, otherwise it will return. Then increment the top. Since one element is inserted, so the top value will be incremented, like the top pointer, what I've told you. Then the element will be inserted. Step 3. S of top, the x টা চলে যাবে. X will be inserted to the S of top and then finished. So it's a simple algorithm. Then the value will be returned. Now let us see an example. On the right side, there is a S vector. Okay. Now stack is empty. Sorry. Top equals to 0, and suppose n equals to 3 for our case. Okay. So push S top comma 10. So what will happen? It is the first element. So it can be inserted because we have created a stack of three elements, and so this is the first element, so it can be inserted. So 10 will be inserted. Top equals to 1, 10 will be inserted. Okay. Second case, again push s comma top comma 8. Since it is a second element and we have we can insert three elements, so 8 will be inserted. Top equals to 2 and 8 is inserted. Here. Now for the third case, push s top minus 5. So minus top will be equals to 3 and minus 5 will be inserted. See, now top equals to 3 and n equals to 3. And suppose if I want to insert one more element, since see the first criteria, step 1, top is greater than equals to n. So when we will try to enter one more element, so top will be incremented, top will be 4. So 4 will be 4 is sorry n is top greater than equals to n. This rule will be violated and there will be a stack overflow. See, I want to insert one more element, push s top comma 6. It will print overflow because we have already three elements and we have already inserted three elements. Clear? So this is how the push algorithm works. Now coming on to the next algorithm. Ashish Patro is saying, sir, are we considering one base index? Yes, definitely. Here we are considering one base index. It is not like array, which is starting from 0. Okay, chalo. So, sorry. Now let us see the second algorithm, which is the pop, which is called deletion. Okay, so pop will be taking the pop algorithm will be taking two parameters. One is s and the second one is top. So this function removes and returns the top element from the stack. Okay, similarly the stack is represented by vector s as earlier and it contains n elements. Okay, and similarly there is a pointer top which represents the top element. Let us see the algorithm. Now we will see for the stack underflow. Step 1. Okay, suppose if the stack is empty, okay, and then we are trying to delete element from the stack, so what will be deleted? Nothing will be deleted. So it will print stack underflow. That is, there is no element in the stack, but we are still trying to pop the elements, so nothing will be popped. So if top equals to 0, then write stack underflow, what I've told. If nothing is in the stack, then it will be stack underflow, then return 0, then decrement the top. As you are deleting the element, the top will be decremented, and then return to the former top element of the stack, return s top plus 1. Let us see an example. This was our previous example. Okay, top equals to 3, we pop s comma top. Okay, s comma top. So the I told you it will delete at LIFO, last in first out. So the last element which was inserted is -5. So -5 will be deleted or -5 will be popped up. So see, -5 will be deleted. Now top equals to 2. Now again we write the function pop s comma top. So what will happen? The next last element is 8. So 8 will be removed and top will be equals to 1. 8 is removed, top equals to 1. And again we try to write pop s comma top. So there is only one element, which is the first element which was inserted, and finally that will be also be removed and top will be equals to 0. See, s is removed, so the stack is empty, top is equals to 0. And if again I write the function pop s comma top, see it will step 1, top equals to 0, write stack underflow. So stack underflow will be printed. See, I try to write pop s comma top and it shows underflow. There is no element that is to be removed or popped from the stack. Clear? Now there is one more function I told you apart from the push and pop, that are the most basic functions, most important function. There is the peep. What is this peep do? This peep function returns the ith element from the top of the stack. So nothing will be deleted or nothing will be inserted. Using this peep function, it will just return the ith element. Suppose you want to see at some point of time, you want to see the ith element from the top of the stack. You want to check the values. So you can use the peep function. This function will not delete anything or will not insert anything. It will just return the value of the ith element. Okay. Ith element, but from the top of the stack. Just remember that. Similarly, stack is represented by S, what I have told you previously. It will contain n elements and I is the ith element. So the function is peep and there are three parameters S, comma top, comma I. For checking for the stack underflow, if there is no element, there is no means in writing the ith element. Okay. So top minus I plus 1, if it is less than 0, then it will write stack underflow, return 0. Otherwise, it will return the ith element from the top of the stack. Return S top minus I plus 1. Okay. See this example. This was our previous example. Peep. I write peep S comma top comma 2. That means the second element from the top of the stack will be deleted. Which element will be deleted? 8. It is not, the graphics is not working in this presentation. Now peep S comma top comma 3. So which one will be deleted? The third element, sorry, not deleted. Which element will be printed, returned? The third from the top. That means 10. The graphics is not working. I'm sorry for that. And if I try to print peep S comma top comma 4, that is the fourth element from the top. It is not possible because there are only 3 elements in the stack. So it will show stack underflow. Okay. Just a sec.
The presentation has stopped, sir.
Yes. I just want to show the graphics. It is not showing in the Google Drive. Now, is it visible? I- Is it visible, guys?
Screen is visible, sir.
Is it visible? See whether I can show the graphics here, because the graphics was not working in the Google Drive. See, peep s comma top comma 2. So the second element from the top, that is 8 will be returned. The value 8 will return. Again, peep s comma top comma 3. That is the third element from the top. That is the 10. Right? So 10 will be returned.
But there is no
And
graphics on the screen.
there is no graphics on screen. No? Sorry for that. I think it is not supporting it because Google Meet has stopped many of its features. You know from the news, latest news. Even the recording, they have also stopped the recording. We cannot record in the Google Meet now. So the third will be peep s comma top comma 4. Thus the fourth element will be deleted. Deleted, will be returned. Okay, the fourth element from the top will be returned. So there is no fourth element because the stack is containing only three variables, three elements. Okay, so it will print stack underflow. Okay, now change. There is one more function which is supported by the stack, that is the change. What is this function? This function actually changes the value of the ith element from the top of the stack to x. Okay, peep was to just peep it. Peep means you know the meaning of peep. Peep means to just to check the ith element from the top of the stack, and change is to change the value of the ith element from the top of the stack. Okay, to x. So you know the function change is having four parameters: s, which is the stack; top is which is the top pointer; x, that is that will be changed, the changed value, the modified value; and
Sir,
yes.
sir, your presentation is not visible at all, sir. Sir, your Google Meet screen is only visible to us.
Oh, sorry. I think now it is visible.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, thank you. So now you will see we uh, we have gone through push, pop, and the third one was peep. Now there is the last function, I think, which is the change, and this is also supported by the stack. And this change, what this change function do? This function changes the value of the ith element from the top of the stack to the x. Okay, and as told earlier, this change function has four parameters: s, top, x, and I. S is the stack vector. Okay, top is the top pointer, which is pointing to the top of the stack. X, which is the modified value, and I is the ith element on the top of the stack. Okay, let us see the algorithm. Step 1. Similarly, if top minus high plus 1 less than equals to 0, we will write stack underflow return, and we will change the ith element, that is the x value of x will be inserted to s of top minus I plus 1 and finished return. Let us see. This was our stack. Change s comma top comma 50 comma 2, that is second element from the top of the stack will be changed to 50. So what is the second value from the top of the stack is 8. So 8 will be changed to 50. Okay, that's 50. Now again change s comma top comma 9 comma 3. So the third element from the top of the stack will be changed to 9. Which is the third element? 10. So 10 will be changed to 9. Okay. Similarly, change s comma top comma 25 comma 8. That is the 8th element from the top of the stack will be changed to 25. But that is not possible since the stack has only 3 elements. So it will print stack underflow. Clear? Now there is an algorithm called recognize. This is actually not there for you. This is all for the CS and IT background students, but you will need in your campus interviews. So write an algorithm which will check that the given string belongs to the following grammar or not. Okay, this is the grammar. That word, any word, there will be a C and then reverse of that word. And word W will belongs to only A or B. Okay, and W word is the reverse of W. Let us see some examples of these strings. A, B, C, B, A. See, A, B is a word, W, suppose A, B is W, and B, A is the reverse of W. Or this may also be one example. A, A, B, B, C, then B, B, A, A. That is the A, B, B is the W, suppose there is C in between, and the reverse of W, that is BBA. And some invalid strings, this may not be possible because AAB, so the reverse
Sir,
is not AAB. Yes,
what is the difference between this question and a question of palindrome string?
it is almost same, but you see that in the question it written the following the given string belongs to the following grammar or not. This grammar term is do not think about this English grammar. It is actually there is a subject in computer science and IT, that automata, that is a language of computers. Okay, you may think as the problem of palindrome maybe is an example of this case. This may be considered, but this is actually belonging to the automata, actually, the which is the language, which is the computer language, how they check. Okay,
Okay, sir.
now let us I am taking the first string, suppose A, B, C, B, A. Okay, and given an input string, suppose there is just input string which is named as string on the alphabet A, B, and A, B, C. Okay, there are a lot of rules for this kind of grammar. Actually, I'm not going into that details of rules for the grammar because that is totally belonging to the CS and IT. But actually, this is a problem which is mostly solved in automata type of subjects, and this is actually solved using the stack. So I am showing one application of the stack where this stack is used for solving this kind of problems, these grammatical problems in computer science. Now, and a string on the alphabet A, B, and C. which contains a blank in this rightmost character position. Okay, the function next char is there. Next char is the function which is returning the next symbol. Okay, here A, B are the actually symbols. And this algorithm determines the contents of the string belongs to the above language or not. And similarly, there is vector S, which is the stack, and top is the pointer, which is pointing to the top element. Now just see the algorithm. First we initialize stack by placing a letter C on the top. Top equals to 1, S of top equals to C. Then we get and push all the symbols until we find a C character or C symbol, say, or a blank is encountered. So next equals to next char will read the string, and until it is equals to C or a blank, it will go on pushing on the elements till it finds a C or a blank. Now the scan characters following C, compare them to the characters on the stack which are on the stack, just compare them. If it not equals to C, then again read the next character and pop one element from the stack and exit. Now next symbol will be must be blank. If it is blank, then it's a valid string, otherwise it's a invalid string. Now let us see an example so it will be clear. Suppose this is our input string A B C B A. I'm taking a simple example, and that A B C B A, and the last one is a blank character. Now the character scan and the stack content. So this was our first step. I told you that we need to first initialize the stack by placing a letter C. So first step is done. Second step, until we get a C or blank, we just going on pushing on the symbols. Next char. So what is next? Next is A. So A is the character which is scanned, and it is pushed onto the stack. Next character is B, and it is pushed onto the stack. Now the next character is C. I told you until we get a C or a blank. So we get a C, so we move out of this step. So this was our second step. Now in the third step, we scan the characters following C and we move the characters one by one. So until we get a C in the stack, we go on scanning the characters and popping it out. So B is the character which is scanned, and B is removed from the stack content. Similarly, A is the next character which is popped up, and we remain with C. Now in the stack we are having C. This is our third step. And since there is C in the stack content remaining, if next equals to blank, the next character is blank actually. The next character is blank after A. So we will write it as valid string. Actually, most of the graphics is not working. That is why I am not able to make it understand you properly. Now this is another example. Write an algorithm to determine if the input character string is of the form a to the power I, b to the power I, where I should be greater than equals to 1. Number of A should be equal to number of B. You can do it as a homework. You can try it at home. This algorithm and how it works. Take an example and just prove it. Whether the input character you have taken follows this kind of grammar or not. A to the power I, b to the power I. Okay. You can take it AABB or AAABBB. This kind of thing. I should be greater than equals to 1. Okay. Now the polish expression and their compilation. Now evaluating and yes,
স্যার
yes,
স্যার
yes.
আগেরটা একটু বোঝাবেন স্যার, বুঝতে পারিনি ঠিক মতো।
আগেরটা অ্যাকচুয়ালি তোমার গ্রাফিক্স গুলো ঠিকঠাক কাজ করছে না। দেখো স্ট্যাক কন্টেন্টে প্রথমে সি আমি পুশ করলাম, ঠিক আছে। সি পুশ করার পরে 1 বাই 1 আমি স্ট্রিংস গুলো স্ক্যান করলাম। ওকে,
স্যার
স্ক্যান করছি স্ট্রিং থেকে, আর স্ট্যাকের মধ্যে আমি পুশ করে দিচ্ছি। দেখো বি স্ক্যান করলাম, অ্যাকচুয়ালি এই কার্সারটা নড়ছে না, নেক্সট কার্সারটা নড়ছে না, নড়া উচিত অ্যাকচুয়ালি, আনটিল উই গেট আ সি। ঠিক আছে, বিটা স্ক্যান করলাম, বি এর পরে দেখো কি আছে, উপরে ইনপুট স্ট্রিং এ সি আছে, সি যাবো না, সি যাবো না, তো ওখানে থেমে গেলাম। এবার স্টেপ 3, সি 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 পেয়েছি, সি এর পরে সিটাকে আমি করলাম, ওভারলুক করলাম। ঠিক আছে, নেক্সট এবার কি, এবার স্ক্যান ক্যারেক্টার্স ফলোইং সি, কম্পেয়ার দেম অন দ্য টু দ্য ক্যারেক্টার্স অন দ্য স্ট্যাক। এবার আমি কম্পেয়ার করছি, নেক্সট ক্যারেক্টারটা কি হচ্ছে, সি এর পরে দেখো বি আছে, বিটা নিলাম। ঠিক আছে, নেক্সট ক্যারেক্টার, নেক্সট হচ্ছে বি। এবার এখানে আমি স্ট্যাকে চেক করছি, আমার স্ট্যাকের টপে কে আছে, স্ট্যাকের টপে কে আছে, বি আছে। ঠিক আছে, এবার এই বিটা দুটো বি, ওটাও নেক্সট ক্যারেক্টারটাও বি, আর স্ট্যাকে কন্টেন্টের টপটাও বি। সো দিস টু আর সিমিলার, সো বি উইল বি রিমুভড। ওকে, আবার আমি নেক্সটে গেলাম, নেক্সটে কি আছে, এ আছে, এটা চেক করলাম। ঠিক আছে, আমার নেক্সট ক্যারেক্টারটাও এ আছে, আর যেটা স্ট্যাকে আমার টপ সেটাও এ আছে, তো সেই জন্য আমি এটাকে পপ করে দিলাম, এটা পপ হয়ে গেল, এখন রয়ে গেল সি। এবার নেক্সট ক্যারেক্টার কি আছে আমার, কি বলবো, ব্ল্যাঙ্ক। নেক্সট ক্যারেক্টার হচ্ছে আমার ব্ল্যাঙ্ক। ইফ নেক্সট ইজ ব্ল্যাঙ্ক, তাহলে আমার স্ট্রিংটা ভ্যালিড স্ট্রিং, মানে দিস এ বি সি বি এ ইজ জাস্টিফাইড, ইজ আ ভ্যালিড স্ট্রিং which will follow this grammar w c w to the power r. Okay, we need to prove it actually, taking any string. You can take it a b b, you can take some invalid string also, a b, which I told you, a b c b a, and just try it whether this rule exists or not, this algorithm works or not. Recognize the algorithm ta, this algorithm will be same. Okay, but you take different input strings and try to match whether it follows the grammar or not. This is a type of grammar, that's w c w reverse, that is any word মাঝখানে c and then reverse of w, the same word will be reverse, and check it whether it follows the grammar or not. Okay,
Okay, sir.
this is a homework, you can try it with this one. This is the algorithm recognize is already given in the previous slide. You just take any string, any input string, and try to follow this kind of algorithm. Okay, so there are mainly 3 types of expression. Okay, infix expression, prefix, and postfix. So how will suppose you get this kind of expression, this is actually infix expression, a plus b into c plus d into d. So what you first do, you will first go with the multiplication sign, that is b into c will be performed, right? Then d into e will be performed, step 2. That is step 3, whatever the result of b into c will be added to a, and finally the whole will be added, d into e result will be added to the result of a plus b into c, right? So a repeated scanning from the left to right is needed as the operator appears inside the operands. Since these operators are inside the operands, so you always need a scanning from left to right. Okay, you need to check from left to right which are the operators which have the first precedence. So you need to perform that operation first, and then we go on left to right continuously checking the operators and the operands. So this type of expression is called infix expression, where the operator appears inside the operands. Suppose a and b are operands and plus is the operator, so operators are appearing inside the operands. It is called infix expression. There are 2 more expressions also, prefix and postfix. In prefix expression, the operators will appear before the operands. And in postfix expression, the operators will appear after the operands. So how we can remove this concept of repeated scanning? Because when we are scanning repeatedly, your algorithm time complexity increases. I am telling about just this small infix expression a plus b into c plus d into e. But in real life, you can get any kind of large expressions. So when you are scanning it repeatedly, that means your time complexity is increasing. So we can do one thing for avoiding this scanning. We can convert this infix expression to its corresponding parenthesis free. That is, there is no need of brackets. Here in infix expression, you can give brackets for giving the precedence, but there no bracket is needed. So what we can do, we can convert the infix expression into its equivalent parenthesis free prefix or postfix, or postfix is also called suffix also. So prefix or postfix. So what is prefix? I told you the operator will appear first and then the operators will appear. So the operator will appear before the operands, and in postfix the operator will appear after the operands. Clear? Now this kind of notation is also called, the prefix notation is sometimes also called polish notation. Okay, it is also known as polish notation. And the reverse polish notation, you call it as postfix. Postfix is also called reverse polish notation. So prefix is also called polish notation, and reverse polish notation is known as the postfix. Now in both the prefix and the postfix equivalents of an infix expression, the variables are in the same relative position. The relative position of the variables will not change, just the operators will change. Here the operators are in infix, the operators are appearing in between the operands. In prefix they will come before, and in postfix they will appear after, but the relative position of the variables will not change. If it is a plus b into c, then a, b, c will appear in the same order. We will look some examples in the next slides. Now the expressions in the postfix or prefix are parenthesis free. I told you there is no need of parenthesis, and the operators are rearranged according to the rules of precedence for the operators. The same rule is followed, based on which arrangement is made. Now let us see example I told you. Now for infix, on the first column you have the infix expressions, and we will write the corresponding postfix and prefix notations. Now this is simple a, no problem. Now a plus b, what will the postfix? AB plus, and what will the prefix? Plus AB. Okay. Now what will happen if a plus b plus c? Now let us see. In a plus b plus c, we will first take a plus b. We are going from left to right, so a plus b. A plus b, first writing, I am writing the postfix first. A b plus c. For the now only we are giving the parenthesis sign, for so that you will not get confused. Now what will happen? A b plus is suppose one expression, and suppose one variable, and c is one variable, and in between there is a plus sign. So what I told you, the operators will appear after in postfix. So plus has been taken out and it is given at the last. So what will the expression comes to now? AB plus C plus. Okay. So we will write AB plus C plus. And what will happen in the infix? Plus plus ABC. Just do it in your home. Similarly for A plus B plus C, see there is a parenthesis given, BC plus, so the precedence is high. So what will happen in the postfix? BC plus, and again in the next step, this plus which is after A will be moved to the last. So ABC plus plus. And what will happen in the prefix? Can anyone tell me? Prefix, what will the prefix?
plus plus ABC.
Plus plus ABC. Na, holo na to. It will be plus and plus of ABC. Since B and C মাঝখানে যেটা এ আছে এরপরে যেটা প্লাসটা আছে সেটা তো আগে চলে যাবে যেহেতু প্রিফিক্স আছে, কিন্তু বি আর সি এর মাঝখানে যেটা আছে ওটা তো আগে যাবে, বি আর সি এর আগে যাবে, বি আর সি এর আগে যাবে, ওর আগে যাবে না।
আচ্ছা
বুঝতে পেরেছো?
হ্যাঁ
সেই জন্য প্লাস এ প্লাস বিসি। ইজ ইট ক্লিয়ার?
হ্যাঁ স্যার।
এবার নেক্সটটা বলো তো কি হবে? এ প্লাস বি ইন্টু সি, তার পোস্টফিক্স কি হবে? এনিওয়ান?
ABC star plus
ABC star plus. Good. And what will be the prefix?
plus A star BC.
Good. And next one, A into B plus C.
ABC plus star.
And in prefix,
Star A plus BC.
good. And what will A into B plus A into B into C?
ABC
ABC
star
star
star.
star.
ABC star C star. And in the prefix it will be star star ABC.
Star A star BC.
Okay, so these are the simple expressions what I have shown in the examples. You will find a lot of expressions for converting into infix to postfix and prefix. There is also one algorithm is there for converting from infix to postfix and infix to prefix. Okay, and in the exam I will give you some bigger expressions. So please try to consult any book and try to solve this kind of problems for converting infix to postfix and infix to prefix and prefix to postfix and postfix to prefix. Anyone can come. Okay, for converting from postfix to prefix, you need to first convert from postfix to infix, and then you can convert infix to prefix. That will be better. That will be safe. Okay. You can try it out some more examples from the book, taking help of the book. Now finding the rank of any expression. How can you find a rank of any expression? Suppose this is an expression given. Okay. Now please note that the rank of any variable is 1 and the rank of any binary operator is -1. So we can break it out like this: rank of A plus rank of plus rank of B. Okay. And in place of variables, I told you rank of variables, that is R of A, R of B, R of C, R of D, R of E, F, G, H, I will be 1. And the binary operators R of plus, R of into, R of divide, R of minus, R of plus again. This will be -1. Okay. And after cancelling it out, we will get rank of E equals to 1. So if the rank of any variable is 1, any expression is 1, that expression is a valid expression. This is how you can check in your examination. If I give some infix expression and told you to check whether any expression, this expression is valid or not, you will just find out the rank. If the rank is 1, the expression is valid. Okay. Now converting infix to postfix. This is one kind of problem. The precedence, the input precedence function. This is, I think, not in your syllabus, but I'm just discussing you because you will need it for CS and IT students. The infix prefix function and the stack precedence function and the rank function. For plus and into, this function f is 1, g is 2, rank is -1. For into and divide, function is 3, stack function is 4. Okay. Now this is there is a given input which is suppose infix containing an infix expression and which has been padded on the right with a closing bracket. Now there is an algorithm which we convert infix to reverse polish. Reverse polish means postfix, and places the result in the string polish, and all the symbols have precedence value given by the table. The table has already been shown in the previous slide. So stack is represented, will be represented by S. Top will be the pointer representing the top of the stack, and the algorithm push and pop will be required for the stack manipulation. The next char function will return the next symbol. The rank will contain the rank of the expression. There will be a variable, string variable, which is called temp, which is used for temporary storage. Let us see the algorithm. First, we initialize stack, and we insert a opening bracket. Okay. Sorry. Then polish is nothing. In polish, polish, I think the reverse polish, there is nothing, so it is initialized to just null. Rank is 0, and we are getting the input char one by one using the next char function, and we are just removing the symbols with greater precedence from the stack in step 5, and in step 6 we are matching the parentheses. And again we are taking the next symbol. If rank equals to rank is not equals to 1 and top is not equals to 0, then it's an invalid expression. Otherwise it's a valid expression. Suppose this is an expression and this is the input symbol, content of the stack, reverse polish expression, and the rank. First I told you opening braces will be included. Rank is 0. And the next character will be scanned. Then the next character is the opening braces. This is the content of the stack. The rank is 0 as told in the table. Then the next character is A. Next symbol is A. A will be pushed to the stack. Rank is 0. Then plus. And if I told you, if see, remove the symbols with greater precision from the stack. If there is if the input symbol is a operator, they'll be remove the one element, the top of the element from the stack, and we keep it in the reverse polish. Like, see, we have encountered a plus. Okay, so we removed A, which was on the top of the stack, and written down to the reverse polish expression. And I told you the rank for the plus is 1, and plus will be inserted. Similarly, B and plus B. Then a cap means cap with the input single. So B will be popped out and AB will be written. Rank will be 2. Again, similarly, C. Again, our operator is encountered. So one element will be popped up. That is, C will be popped up. ABC. Rank will be 3. And again, we encountered a D. D will be inserted. ABC, D. Then the closing braces is encountered. Once the closing braces is encountered, all the elements will be popped up of the stack and will be written in the reverse manner. Okay. And the rank will be 1. So you can do it for all the expressions. It is not working. The graphic is not working. You can do it for the total expression. I am just showing it for A plus B, cap C, cap D. You can do it for all the expressions, the entire expression into E plus F by D. Now, you can also convert this infix expression to the postfix. This is for your homework. And to convert the infix to the prefix, this is also for your homework. You can take the help of the book and try to solve it out, converting infix to postfix and infix to prefix, and you should also show the stack contents in the exam also. If I've given a infix expression and I told you to write a postfix expression, it will come off for 4 marks or 5 marks. So you just calculate it in the rough column and you just write the one line postfix expression. That will not do. You have to show the stack content for every step, that a plus b. So a and b are going into the stack, then plus plus will be popped up. You need to show the entire stack contents, how it is going. Then you will get 4 out of 4 or 5 out of 5. Okay, just not write one expression, one line for the postfix. Maybe it may be correct, but you have to show the stack contents. Otherwise, you will get only 50% of the marks. Now, general infix to postfix conversion. Create an empty stack for keeping the operators and create an empty list for the output. Now read the characters from the left to right and perform the following step. কি step follow করব? Step 1, if the character is an operand or variable, just append it to the end of output list. If the character is a left parenthesis, push it on to the stack. If the character is a right parenthesis, pop the stack until the corresponding left parenthesis is removed, and append each operator to the end of the output list. If the token is an operator, multiplication or division or plus or minus, push it on to the stack. However, first remove any characters which are already on the stack that have higher or equal precedence and append them to the output list. So this is the algorithm which you should follow for converting from postfix infix to postfix. Now, how will we evaluate a postfix expression? It may also come in the exam. I have given you an postfix expression. So you should not, there is one way out that you can convert it first into infix, but directly you can evaluate the postfix expression. How we can do it? Now each operator in the postfix string refers to the previous two operands that we know. And each time we read in an operand, we push it onto the stack. And when we reach an operator, we will remove the top two elements and perform that operation. See, we can pop these elements, perform the operation, and just push the result into the stack so that it can be available for use for the next operator. In the similar way, we can do that. Just see an example. 5, 6, 2 minus plus. This is a postfix expression, right? We will take an empty stack and the output stack. Now read 5. Is it operand? Yes, it is operand. So we will push into the stack. 5 is pushed. Next 6. 6 is also operand. So we'll push into the stack. Then 2. 2 is also operand. So push it onto the stack. Next, what we see? There is a minus. So what we will do? We will pop the top two elements from the stack, that is 6 minus 2, perform the operation. 6 minus 2 is 4, and then again put it in the top of the stack. 4. See, since we are operating a minus, so pop two symbols. So operator 1 minus operator 2, 5, and 6 minus 2 is 4. So 4 we will again push it to the stack.
Sir, could you please explain it again, because I didn't get it.
From the beginning. See,
Yes, sir. Yes.
this is the expression 5, 6, 2 minus plus. This is a postfix expression, right? So what we will do? We will take an empty stack first, and if we encountered, we will scan from left to right as usual. If we encountered operand, we will push into the stack until we get a operator. Once we get an operator, we will pop the top two elements of the stack, perform the operation, and just keep the result on the top of the stack. Okay. So this is an empty stack. What is the first element, which is 5? 5 5 is a operand, so we will push it. Again 6, next element is 6. 6 is a operand, again we will push it. Next operand, next element is 2, which is again an operand, we again push it. Next, what we will see, we will next element is minus. So minus is an operator. So what I have told you, if we encounter an operator, we will pop the first two elements. So 6 and 2 will be popped up, operation will be performed, that is 6 minus 2, and the result is 4. So 4 will be pushed into the stack for the next operation. And what is the next element? Next element is plus. Plus is again an operator. So what we will do, we will pop the first two elements of the stack. What are the first two elements? 5 and 4. We will perform the operation, that is 5 plus 4, and the result will be pushed to the stack. Fine. And whatever will be the value of the stack will be the value of the postfix expression. Is it clear?
Yes, sir. Sir, do I have to write down any code for showing this, like these types of algorithm?
No, you can do it as shown in the slide, but you not have to write much more. You can write like that after scanning the expression from the left to right, it is encountered that the first three elements, that is 5, 6 and 2, are operands. So we are pushing onto the stack. Stack এ করে একটা দেখিয়ে দেবে এটা। Next
Okay.
next slide, next operator is minus. So we perform the operation and push the result into the stack, and just push it and show the stack. You need to show the stack content after every step. You need to show the stack content. That is much
Yes.
more important.
Yes, sir. Sir, we will have to like write down the diagrams.
Yes, you can write. You can do it. That is what I'm telling. After every step, suppose step 1, step 2, step 3, step 4, write 1 or 2 lines and show the stack content for
Yes,
every
sir.
case. For infix to postfix, postfix to prefix, you need to write the, and in some questions I will also tell you to write the algorithm only. I can
Okay.
say you to just write the algorithm for converting infix to postfix. It may happen. So you can just write this algorithm, infix to postfix conversion algorithm. You can write this in the form of algorithm. This is actually an algorithm. Okay.
Yes, sir.
See, this is an algorithm. Evaluate postfix. This is an algorithm. The input string is postfix, which is representing the postfix expression. The algorithm evaluates postfix expression, and the final results we are keeping into the variable which is named as value. Stack is represented by S. Top is the pointer, again, which is pointing to the top of the stack. Push and pop will be required for stack manipulation. And next char is the next symbol, which is scan. Operand 1, operand 2, and temp are the temporary variables. 3 variables are there. And perform operation is also a function which is performing that operation. See, this is the algorithm. I think I did not have to explain this algorithm. Sorry. This is the algorithm. I tell you to write just the algorithm, just write the algorithm, because you don't have any lab for this subject. So I cannot tell you to write any C code or C++ code or Java code. Okay. Any type of code I cannot tell you to write in particular programming language. So if you want, you can follow any programming language, or if you want, you can write just the algorithm. That will be better.
Sir, one more thing. Could you send me the previous year questions with us? Then we will be like working on that. And
PDF questions.
It will get clear to us.
See, I have mailed you 3 ebooks. Okay. Bala Guruswamy, Thareja, Rima Thareja, and that ES1 connector, I think.
Yes,
These 3 are the basic books, and the questions will be mostly from those books. Okay. There is a question answer part at the end of all the chapters. You will find there are some questions given after every chapter.
yes.
Okay, you can go through that questions. That questions will come. That type of question will come.
Okay, sir.
I will not give you any innovative type of questions. Questions will come from directly from there, because I will mostly follow those books for setting the question paper. Okay. But I am
Okay,
telling you the types of the question, the pattern types. The pattern types will be like this: algorithm, or for evaluating the expression. The question will be very straightforward. But you need to practice it so that you can complete your paper on time. Okay.
okay, sir.
Now these are the expressions. You can do it at your home as a homework. The postfix expression I've given you. For the last expression, there is no comma. A comma was unintentionally put by me. Okay. So do it in your home. And for the evaluate prefix also, there is an input string prefix. Uh, the algorithm evaluates the prefix expression, and the result is put in the variable value. S is the stack, top is the pointer pointing to the top of the stack. Push and pop, which are used for the stack manipulation. Next char function will scan the next symbol. Operand 1, operand 2, and temp are the temporary variables. Perform operation will perform the operation on operand 1 and operand 2. So this is the algorithm which goes for the evaluation of the prefix. Very simple algorithm, same as the postfix. You can go through it. Next comes the recursion. Recursion is already taught in your previous semester. It is basically a procedure that contains a procedure calls to itself. That is called recursion, or a procedure call, you may say, to second procedure, which eventually calls the first procedure. That is also called a recursive procedure. There are two important conditions for any recursive procedure. Each time a procedure calls, when it calls itself, it must be nearer in some sense to a solution. That means it must not go to any infinite loop, in infinite recursion. And what is the second condition? Second condition is there must be some decision criterion. So there should be some stopping criteria. Otherwise, your program will go on in recursive manner, and your entire screen will be filled up with the outputs. Now there are two types of recursion: primitive, non-primitive. Primitive is a recursive defined function. You will define a function for it and just call it, like the factorial function. And non-primitive is this is the recursive use of the procedure. Here the procedure is called recursively. Okay, and in the primitive, in itself the function, the recursion is made. The function is made recursive, but here in the procedure we are calling the values so that it can recursively give the answers, like finding the GCD or LCM of two numbers. Now coming on to the Q part. I think let us take a break for 5 minutes. Okay, then we can continue. That will be better. Guys,
Yes, sir.
just take a 5 minutes break. Now it is 3:42. We will start at 3:47. Okay. Yes, Parvez. So we can start. Now, moving on to the unit 3, that is the queue. So stack is over and we are moving on to the queue. So queue, as the name suggests, you are understand that a queue just it's a line. Let's say it is also a linear list like a stack, but the rule is a bit different. What is the rule here? It permits the deletion to be performed at one end and insertion at the other end. So what was happening in the in a stack, the insertion and deletion is been performed from only one end, that is from the top of the stack only. But in queue, the insertion will be performed at one end and the deletion will be performed at the other end. So this is called a queue, and the processing is done in a FIFO manner, first in first out, or you can say it FCFS, first come first serve. That is, the first element which is inserted at the in the queue will be the first element which will be move out of the queue, and front is the end of the queue. From that, deletion is to be performed. So the deletion is performed from the front end, and rear is the end of the queue. Rear is known as the end of the queue at which the new element is to be inserted. So you can delete the element from the front of the queue, and you can add the element, insert the element at the from the rear of the queue. Okay, so this terms please keep in mind: front, rear. Okay, and the insertion operation is called the NQ operation, and the deletion operation is called the DQ. Like unlike in stack, which is in insertion operation is called push, deletion is called pop. Here the insertion operation is called NQ and the deletion operation is called the DQ. Okay, this is a stack. See, first there is a element 10, then the insertion is done from the end, and this is how the from the front the deletion is made and insertion is made on the rear. Now what are the applications of queue? The queue of people at any service point, such as ticketing. You can see in ticket reservation. Queue of airplanes waiting for the landing instructions. Queue of processes in operating system. There in operating system there are many processes which are in queue, and they are just processed one by one. Which enters the queue first will be processed first. Queue is also used by the operating system for job scheduling. In operating system, you also use queue for the job scheduling of the jobs, which job will be done first. And when a resource is shared among multiple consumers, suppose in case of printers, the first one to be entered is to the first one is to be processed. And when data is transferred asynchronously, that is data not necessarily received at the same rate as sent in the true process, queue is required, like the IO buffers, the pipes, and file inputs, input output. And queue is also used in BFS algorithm. You know BFS, breadth first. It helps in traversing a tree or graph. We will look this tree and graph in the non-linear data structure part. We are just not dealing with the linear data structure. And queue is also used in networking to handle the congestion. Now, I told you there are two algorithms, NQ and DQ. NQ is for insertion, DQ is for deletion. Now let us see the algorithms for the NQ and DQ. The NQ has 5 parameters, Q, F, R, N, Y. Let us see one by one. This procedure inserts Y at the rear end of the queue. So Y is the element which is to be inserted at the rear end. Now q is represented by a vector q and n is the number of elements. Okay. F is the pointer which is pointing to the front element of the queue, and R is the pointer which is pointing to the rear element of the queue. Clear? So insert Q is the vector, F is the pointer to the front element, R is the pointer to the rear element, N is the total number of elements, and Y is the element which is to be inserted. Now first we check for Q overflow. Q overflow as in the stack overflow also we have seen. And if it is okay, then we will increment the rear pointer since the insertion can only be made from the end. So the rear pointer will be incremented and element will be inserted. And we will just check for the front pointer also if it is properly set or not, because it may happen there is only one element in the queue or there is no element in the queue. So we are inserting the first element in the queue, just a first element. So the pointers need to be reset actually. See, n equals to 3, r equals to 0, f equals to 0. The number of element is 3. F equals to 0, r equals to 0. nq, nq, we are calling the function nq, q, comma f, comma r, comma n is 3, and y is 5. So we want to insert 5. 5 is inserted, right? So when 5 will inserted, f will be 0 and r will be 1. Rear is 1 and f will be also be 1. So now when the element is inserted, first element is inserted in the queue, f is also 1 and r is also 1, and they are both pointing to the same element. Okay. After the next element is inserted, see again the nq function is called and we need to insert 20 element is 20. So what will happen? The rear will be increased, r will be 2, f will be 1, r will be 2, and y will be inserted. And see, the rear pointer is not shifting. The rear pointer will be shift actually. And again, when we are calling the nq function, y equals to 80, we want to insert 80, rear will be increased, r value will be increased, and 80 will be inserted. And suppose we again want to call this nq function, it will give the output as q overflow, since there is only 3 elements, n equals to 3. Similarly in dq, for deletion we have just for the dq function we are having just 3 parameters, q, comma f, comma r. Q is the vector q having n number of elements, and f and r is the pointer to the front and rear end of the queue respectively. And this function will delete and returns an element from the front end of the queue. So deletion should be done at the front end only. So we will first check for the queue underflow. As I told you, if it is not underflowing, so we will delete the element and the values of f and r will be updated. Okay, if f equals to r, that is if you're trying to delete the only element which is existing in the queue, so f equals to r equals to 0. So the pointer to the front element and rear element will be equals to 0. Otherwise f will be equals to f plus 1 since we have deleted it. See, for case number 1, if f equals to 0, r equals to 0. Case number 2, f equals to 3, r equals to 3. F and r are pointing to the same pointer. F equal to 0, r equals to 0. F equals to 1, R equals to 3. F is pointing to 5 and R is pointing to 50. F equals to 2, R equals to 3. Now, example of the queue insert or delete. Suppose we want, suppose there is a queue which is having of size of 4, and we will draw the queue after each operation. Suppose there are some set of operations which are given: insert A, insert B, insert C, delete A, delete B, insert D, and insert E. So this is an empty queue of size 4. F is 0, R is 0. Okay. So what is the first operation? Insert A. So A will be inserted. A will be inserted and R will be equals to 1. And F will be also equals to 1. Since the front and rear pointers are pointing to the only element, which is A. Again, insert B. The second operation is insert B. So R will be 2, because insertion can be made from the end only. So R will be 2, F will be 1. So there is B. Again, insert C. So C will be inserted. R will be 3, F will be 1. Again, the next function is, next operation is delete A. So A will be deleted. So now F and R is pointing to A and C. So R will be 3 and F will be 2. Next operation is delete B. So R will be 3 and F will be 3. Since we are deleting it, so F will be F plus 1. Now next function is, next operation is insert D. So now F and R are pointing to C only. After inserting D, R will be 4, the rear will be increased, the rear pointer will be increased, but F will be equals to 3 only. D will be inserted. Now again, insert E. Okay, so where this E will be inserted? Any idea? Guys, any idea for this? Where this E element will be inserted? Anyone? No one? Can you tell me where this E will be inserted? The next operation is insert E. So where this E will be inserted?
Sir, besides C?
Besides C? No. This is the problem of the queue. This is the limitation of the queue. When you are giving it insert E, F is pointing to C and R is pointing to D. That is the value of F is 3 and R is 4. R means the rear pointer. And if you want to insert E, what will happen? The rear pointer will increase, right? After inserting, the rear pointer will increase. So R will be 5, which is not possible. Why? The queue size is 4. That is N equals to 4. Okay, and R should not exceed N. That is the criteria of queue, because you can insert it from the rear end, right? And the rear is pointing to the 4th element now. So how can we insert the 5th element? in spite of the fact the first two positions are actually empty, but still now we cannot insert. See, r equals to 4, n equals to 4. Actually, after inserting, r will be equals to 5. And that should not be possible. It should not increase, r should not increase the size of the queue. So there will be a queue overflow. But it is fact that it is a queue overflow conceptually, but space is there in the queue. You can see that there is a space. There are two spaces empty for inserting E. Still now we cannot insert it. That is, this will lead to the memory wastage. This was one of the biggest disadvantages of using queue. Okay, so this problem was overcome by using the circular queue. Okay, what is a circular queue? It is actually a simple queue which will prevent the use of the excessive use of the memory, and it will arrange the elements like q1, q2, qn in a circular fashion. Previously it was in a linear fashion. Now it will be in a circular fashion. So it is called circular queue. And what is the speciality of this circular queue? In circular queue, the last node is connected back to the first node to make a circle. And it follows the FIFO principle. It is also sometimes called the ring buffer. See, this was our normal queue. And in circular queue, the last element will point to the first element. Or you can say like that. You can visualize like that. In the suppose 0, 1, 2, 3, 4, 5, 6, 7. The first element is pointing to the front pointer is pointing to the first element, and the rear will be this will prevent the excessive use of the memory, with the wastage of memory, which was wasted in case of the queue. Now similarly there circular queue insert, circular queue delete, CQ insert and CQ delete. Okay. Similarly, like NQ, it also CQ insert also takes 5 parameters: F, R, Q, N, Y. You know all these parameters. F is the front pointer, Y is the rear pointer, Q is the vector Q, N is the number of element, and Y is the element which needs to be inserted. Now we first reset the rear pointer for inserting the queue. R equals to N. If R equals to N, যদি R equals to N থাকে, then R will be equals to 1. Else R equals to R plus 1. And if F equals to R, if the front pointer and the rear pointer are pointing to the same element, that means it's overflow. No element can be inserted. Now we insert the element and we again set the front pointer. Okay, just see in the diagram. Now pointing to the 8 and 15. Now R will be pointing to the last element. If it is pointing to the last element, R equals to N, R will be equals to 1. And it will again take the insert the elements. The second one is the CQ delete. Similarly, like DQ, it is the CQ delete. Takes 4 parameters: F, R, Q, N. F and R are the front pointer and the rear pointer. R is the rear pointer. Q is the vector Q, and N is the number of elements. Similarly, first we check for the underflow. And if there is no underflow, we will delete the element and update the front pointer. Since the deletion is done from the front, so we will delete the front pointer, update the front pointer. Now the similar example which we have taken, empty queue, insert A, so A is inserted, F equals to 1, front pointer 1, R equals to 1, then insert B. F and R was pointing to the first point, was pointing to the same element, that is A. After inserting B, R will be 2. Okay, then insert C, C will be inserted, R will be 3, R will be incremented after insertion. Delete A will be deleted, so the front pointer will increase, F will be 2. Then again delete B, front pointer will be increased, F equals to 3 and R will be also equals to 3. Then insert D, R will be 4 since we are inserting it, so the rear pointer will increase, R will be equals to R plus 1. So we will insert D, and after again inserting E, see the pointer is updated. The front and rear the rear pointer is updated. Since R equals to 4 and 4 is equals to 4 equals to the size of the Q, so R will be equals to 1. It is updated and E will be inserted. Is it clear? Now a DQ. What is a DQ? It's a double-ended queue. It's a linear list in which the insertion and deletion are performed from either end of the structure. What I have told in queue, that there is insertion can be done from the end and deletion can be done only from the front. And then we see the circular queue, the CQ, where the elements are arranged in a circular fashion, in a circular queue, circular manner. And now we are moving on to the double-ended queue, in which you can insert or delete from either end. You don't need to move to till the end of the list to delete any value. And there are two variations of DQ: input restricted DQ and output restricted DQ. Input restricted DQ. What is input restricted DQ? It allows the insertions at only one end, and the output restricted DQ, it allows the deletion from only one end. And the DQ algorithms, DQ insert rear is the same as the Q insert NQ, which I have already explained to you, and the DQ delete front is same as the Q delete, that is the DQ function already discussed. And the DQ insert front and DQ insert rear. See, this is the front and rear of the queue, and deletion is done from the front and insertion is done from the front. And the DQ insertion can also be done from the front and deletion can also be done from the rear. Now let us see the DQ insert front and DQ delete rear. Now DQ insert front, it is again taking 5 parameters: Q, F, R, N, Y. Q is the vector, F is the front pointer, R is the rear pointer, N is the number of elements, and Y is the element to be inserted at the front end of the circular queue. First we check for the overflow before inserting it, and if it is not overflowing, then we will decrement the front pointer and insert the element. We check for the overflow and we'll insert that. And in DQ delete rear, it will take the 3 parameters QFR. Q is the vector, F and R are the front and rear pointers, and deletion is done from the rear end. First we check for the underflow, whether there is element exist or not. If the element exists, we will delete the element and update the rear pointers. Next, coming on to the priority queue. What is a priority queue? A queue in which we are able to insert or remove items from any position based on some priority. Okay. Here also it is like a D queue where we can insert or remove items from any position, but based on some priority. Okay. What is this priority? Priority 1 will be the real-time jobs. Priority 2 will be the online jobs. Priority 3 will be the batch processing job. Okay, and therefore if a job is initiated with priority I, it is inserted immediately at the end of the list of the jobs with priorities I, and jobs are also removed from the front end of the queue. See, the priorities are RI, OJ, and BK. RI the real-time jobs, O is the online jobs, and B is the batch processing jobs. A priority queue viewed as a single queue with insertion allowed at any position. These are the three priorities. These are made to visible like in a single array. It is looking like a single array, but actually there are three priority queues within a single queue. Within a single queue, you are finding three priority queues. Okay, let us stop up to here, or shall I complete the linked list also? I have time.
No, sir, it's okay, sir. You can stop.
You can stop. Okay, because I'm not feeling well. I'm still
Yes,
very
sir.
weak.
Sir, I've asked about this in our batch. They were saying that if you can share the PDF and the PPT, it will be
Okay.
fine. We can study from the PPT itself.
Okay. Okay. Oh, thank you. Now let us take the attendance. Now I can try how much I can take my classes. If it is not possible, I will give the slides. But let me try first. Because if the department asks, since it's a non-departmental subject, and you will be asked to give feedback that how I have taught you, and if someone says that there were no classes, so it will be not a good reputation for me or for our department. Okay, so I will try to take my classes as much I can, and if it is not possible, I will share the slides. Okay. Roll number 1.
Present, sir.
You just entered right now.
No, sir. I was there. No,
I
sir.
was there. Okay. Roll number 5.
Yes, sir.
6. 6. 7. 9 is present. 29 is present. Ashish, please mute yourself. 9 is present. Yes. 29 is also present. Okay. 32 is also present. I saw. 41. 42. 43. 44.
Present, sir.
Okay. 46 is present, I think. 46 is present. Rion Samanto? I saw him.
Yes, sir. Rion is there in the meets.
Rion is there.
Yes, sir. His mic is not working.
47?
So what about roll number 29?
Yes, you are present.
Present.
Subrin, I have given you.
Okay, sir.
47?
Yes, sir.
47?
Present. Yes, sir. Present.
Yes. 48 is present.
Present, sir.
49 is 49. 50.
Yes, sir, present.
51 is present. 52 is also present. 50, 60. 60. 61. 65. 66 is present. I think.
Sir? 66.
I saw you. 68.
Present, sir.
70. 72. 74. 75. Yes, 74 is present. Parvez, I've given you. 75.
Yes.
75, 76, 77, 78, 79,
Present, sir.
80, 81, 82,
Present, sir.
82,
Yes, sir.
yes.
82.
83,
Yes, sir. Present.
84,
Present, sir.
85 is present, 86, 86, 87, 88, 89, 90,
Present, sir. Present, sir.
90 is present, na?
Yes, sir.
91, 92, 93, 94, 94, 95 is present,
Present, sir.
96,
Present, sir.
98, 99,
Present, sir.
100, 101, 102, 100, no, sorry, 2019, Biplab Mahapatra. Achha, 2001,
Present, sir.
2002,
Yes, sir. Present, sir.
2003,
Present, sir.
2004,
Present, sir.
2005,
Present, sir.
2006, 2007.
Present, sir.
Okay. So today class is over. Let's meet on 4th. Okay. 4th or 5th is Friday. The class is at I think 10 o'clock, right? Joydeep?
Yes, sir.
Okay. Let's meet on 4th Feb, 10 o'clock.
Sir, if your health is not okay, then keep the class off.
No. I need to complete the syllabus because from the month of March, the first years, I will have to take the first year labs, CPNM lab. They are all 4 hours lab. And I think out of 5 days, I have labs on 4 days. So it will be a very busy, hectic schedule. So I want to complete it as much I can. And if I'm not able to complete, I will give the slides.
Okay, sir. Okay, sir.
Okay, Friday just 10 o'clock, right? Just meet on 10 o'clock.
Yes, sir.
Bye. Thank you.